Okay, so the win-loss record again is I am almost willing to discard it. The one thing I can say about win-loss is that it most is very closely to aligned with what the pitcher's team is trying to do. They're trying to win the game, and what you'll see in a lot of these other possible statistics that we can use, they're kind of a departure from the real point of baseball, which is winning the game. So let me introduce those. The next most common way, in fact, a very, very common way of evaluating pitchers' performance is called the earned run average, or it's also abbreviated ERA. What this essentially means is it calculates the number of runs scored against a pitcher that were earned. Now I'll find that in a second. As though the pitcher pitched not the entire game. Okay, so for example, if the pitcher gives up 3 earned runs well, 3 is a bad number. 2 earned runs in 6 innings. So meaning they only pitched 6 out of the 9 innings, but gave up 2 runs during that process. That would be the equivalent of giving up 3 runs for 9 innings, right? Because basically 2 runs in 6 innings is like 1 run every 3 innings. So it would end up being 3 runs in a 9-inning game. Now, if that happened, if a pitcher were to give up 2 earned runs in 6 innings, they would have an earned run average, or an ERA, of 3.0, basically exactly 3 runs, as though they pitched all 9 innings. Okay, so an earned run average is a very common way of measuring the performance of the pitcher. Now, it takes into account unearned runs versus earned runs. So the difference there is that if a pitcher gives up a run, but the run happens because one of his fielders made an error, that's not really the pitcher's fault. And so that would be what's called an unearned run if the run scored because of an error. So there's a whole bunch of rules to decide what's an unearned run and what's an earned run. But essentially, the earned runs only really measure the runs scored against the pitcher that were really the pitcher's fault. Okay. So again, it tends to be a very good measure of the performance of the pitcher. The pros of this approach is again, it's closer to the result that matters, which is the total number of runs scored. It also removes the penalty for runs scored by error, as I mentioned, and it also awards a pitcher who pitches out of jams, meaning that if a pitcher were to give up a whole bunch of hits during an inning, like let's say to load the bases, let's say 3 consecutive singles to load the bases, and then the pitcher really bears down and gets the next 3 guys out, and no runs are scored. Well, that's actually just as good, really, as if the pitcher got everybody out in the first place, because no runs scored, and that is what matters during the game. Okay. The cons of this approach is that it's very dependent upon the quality of the defense. If you have a really good defense behind you, meaning they make really spectacular plays or they make all the plays, then the amount of runs given up by the pitcher will be less. The other downside of this approach, though, is that I'm going to leave that one. I'll leave that one alone. I'll tell you about that one separately. So there you go. That's ERA in a nutshell. The next statistic. One thing about ERA, of course, is numerical. So we can plot it and we can do statistical analysis on it, which is good. And if you think about it, this is kind of interesting. Is that the actual performance of the pitcher during a game? What we're looking for is a way of numerically measuring this in some way, so that we can indeed do these sorts of analysis. So ERA is certainly one of those numbers. What you'll see later, though, is you'll see that it actually has some downside in that it's not typically very normally distributed. If you remember, the book always talks about that. So that's one of the other statistical downsides of using ERA. The second measure is something called WHIP. WHIP is the acronym, and it stands for walks and hits per innings pitched. So what this is, it's similar to ERA in that it measures how many bad things, if you will, the pitcher gives up divided by the number of innings pitched. So what walks and hits per innings pitched does is what you do is you add up the number of walks and the number of hits that the pitcher has yielded in a game, and then you divide by the number of innings that the pitcher pitched. So let's say that the pitcher gives up, let's say, 6 hits and 4 walks, let's say, and only pitches 5 innings. Well, 6 hits plus 4 walks is 10, divided by 5 innings, 5, so 10 divided by 5 would be 2. So that would be a WHIP of 2.0 in that situation, which, by the way, isn't very good. A good WHIP is somewhere kind of in the 1.5 region. A very good WHIP is like 1.0, and a ridiculously good WHIP would be like 0 or 0.2 or something like that. It's super uncommon to have a WHIP of 0, because that essentially means you've pitched a bunch of innings and haven't given up a single walk or hit. Very rare event. It does happen. It's called a perfect game when you do that for 9 innings, but it's kind of rare. So the pros of using WHIP is that well, let's see. I'm going to get away from these pros and cons. I'll talk to you about that separately. But there's some pluses and minuses of using WHIP versus ERA. One thing I can say is that statistically, WHIP is much more normally distributed. When you plot the WHIP for a pitcher during a game, the actual values kind of fall in a regular kind of normal distribution, which is not the same the thing that you would say about ERA. So WHIP is a better numerical representation, I think, for what we want to do. I contend it's weaker in certain areas, but I'm going to save that because that's kind of a detail. The third, I guess it's not third now, it's fourth approach. So I covered win-loss, I covered ERA, and I covered a WHIP. The fourth is something called a quality start, or QS. I'm going to break here, though, and start another video.